Here's a couple of examples that will hopefully help you with your homework. So this is part of relationships outcome 1.1. So we've got information for us to create an equation for a line. So you've got the gradient, so remember m equals 2, and you've got x and y. Okay, and we want to create the equation and simplify it. So what we've got is the equation y equals mx plus c. So what we have here is we have to try and find c first of all. So what we can do is substitute these values in. So we know y is 5, we know m is 2, we know x is 4 plus c. Okay, so what we can do is let's say 5 equals 8 plus c. So we'll subtract 8 from this side, subtract 8 from this side, so c equals minus 3. So what we can now do is we can now put this into the equation. So we revisit this equation here. We then can say y equals 2x and minus 3. So that's the equation of that line that has that gradient and it passes through this point. This one is an inequality, so you just solve it the same way you would a normal equation. So what we've got here is 5x plus 3 is less than 3x plus 11, so we're going to subtract 3 away from both sides, so we end up with 5x is less than 3x plus 8, because we take away 3 from that side. We're then going to get rid of the 3x there, so we're going to subtract 3x, so that'll give us 2x is less than 8. And we can still get into the form of what x is by dividing both sides by 2. So what we do is x is less than 4. And that's your answer. Here's an example of simultaneous equations. So we've got two equations and we're going to try and find both of these unknowns. So what we need to do first of all is eliminate one of these unknowns. So I'm going to number these equations and I'm going to try and get rid of the y's. So we've got 4x plus 3y equals 17, we've got 5x minus y equals 7. I'm going to try and get this up to a minus 3y, and then we can add these equations and we'll get rid of the y. So I'm going to times equation 2 by 3. So we then say, well, this is a third equation, 15x minus 3y equals 21, and we're going to call this equation 3. Now if we actually add equation 1 to equation 3, so add equation 1 plus equation 3, what we'll end up having is an equation in which we've eliminated y. And what I mean by that is if we go 4x plus 15x, that's 19x, 3y plus minus 3y is 0, then we have 17 plus 21 and that's 38. Okay, so 19x equals 38, so x equals 2. What we then do is we then put this value of x and we can substitute it into one of the equations. Okay, so I'm going to choose just back to the first equation. But now we know what x is, so it's 4 times 2 plus 3y equals 17. So that's 8 plus 3y equals 17. Take 8 away from that side, so I need to take it from that side, so that's 3y equals 9, so y equals 3. And that's just got the two values. Now, next we have a question. Here I was changing the subject to the formula, so we've got y equals 2x plus p, we want to get it into the form of y. First thing I do is I just rewrite it so the subject's on the left hand side. I can now think, well, I want to get rid of p from this side, so I need to subtract it from this side, so 2x equals y minus p. I need to then divide this side, divide that by 2, so it's just an x, so I have to divide that side by 2. So I end up with x equals y minus p divided by 2. And that's your answer for this question. We want to work out if this is a right angle triangle. Okay, so what we have to do is just apply Pythagoras. So we've got C, call that A if you want, call that B, as long as you're calling that C. Now if this is a right angle triangle, what you'll find is C squared equals A squared plus B squared. So we just plug in the numbers, so 19 squared, that should equal the same as
11.7 squared plus 15.6 squared. And just put these values in your calculator. So we have 19.5 squared. So that equals 380.25. That should equal that. So if I now go 11.7 squared plus 15.6 squared, that equals the same. So we can just say, therefore, the right angle triangle, just say as c squared equals a squared plus b squared. So remember to label these, and that's hopefully answered that question. Now, these type of questions are looking for you to understand angles within a polygon. Okay, so what we've got here is a very poorly drawn polygon, but they're wanting to work out these angles there. Now, what you'll find is all these angles are equal. So what we know of that is all these angles are being shared by 360 degrees, so it goes round in a full circle. So we just count how many segments. So there's 1, 2, 3, 4, 5, 6. Divide that by 6. So each of these segments is 60 degrees. We also know that each of these individual triangles is an isosceles, so that angle and that angle has to be the same. So remember, a triangle has 180 degrees. We can account for 60 degrees out of it with that angle, so that now gives us 120 degrees to play with. And 120 divided by 2, because they're equally shared, these are also 60 degrees. Okay, so one of these angles is 60 degrees, so therefore these two angles joined together, it's just 2 times 60. So effectively this shaded angle is 120 degrees. Right, this one they're wanting you just to sketch this. Okay, now what we do is we know that this is the amplitude. Right, so amplitude is 2. So if we look at your normal sine wave, it goes from -1 up to 1, 180, and that's the period of this wave. Okay, so the whole wavelength goes from down to there, so that's a wavelength. All we've done when it's 2 sine is we actually have it go up to 2, so the amplitude is 2. So up to 2 and then down to -2. So what we do, wavelength is the exact same, it crosses 180, but it's just doubled in amplitude. Okay, so I'll just go for it in the black pen. Right. Not the best drawing. So you've just taken a wave and just stretched up that way. What they're asking here is they're asking what's the period of the wave. So what we've got here is this is essentially the number of waves between 0 to 360. So they've managed to cram in 3 waves. So to find the period, you just get 360 divided by that number, and that gives you 120. So that's the period of that. Cos equals 3x. And I should have one more wee question, and they're just looking for the values of x degrees. So what we've got here is we've got 10 sine x minus 1. First thing you do is just draw your wee cast diagram. So they're positive in the first quadrant, sine's positive in the second, tan's positive in the third, and cos is positive in the fourth. So we rearrange this so it's sine x equals. So what we do, 10 sine x degrees, add 1 to this, so I have to add 1 to that side, and then divide this side by 10, so we end up with sine x degrees equals a 10th. So that's positive, right? So this is positive, so it's positive here, and it's positive here. So to find x degrees, we'll just take the inverse of sine of 1/10. Just put on your calculator, we then go shift, inverse, and 1/10, same as 0.1. So that equals 5.74 degrees. Okay, so that equals 5.74 degrees. Now, that's for quadrant 1. For quadrant 2, what we're going to do here is we're just essentially just going to be taking it away from 180. So that's 180 minus 5.74 degrees. For quadrant 1, for quadrant 2, that's going to be 180 minus 5.74. That is going to give us 174.26. Okay, so remember what your sine wave looks like. So what we've got here is it's cutting through it at 2 points. One point is when it's at 5.74 degrees, the other point is when it's 170.26 degrees. But that's really important that you remember that. So remember that's just effectively x degrees. That's 180 minus x. You would add it onto 180 plus x, and that's 360 minus your x degrees. Hopefully that's helped for your homework.